My name is Shivashi Chakraborty. Today I will enlighten you about Himalayas. So the Great Himalayas is one of the reasons why India is famous for. So it is shocking that how such mountains were formed. It is true that such great Himalaya mountain of like 8,848 meter of highest peak was not present from the beginning of the earth. It was formed like near 50 to 80 million years ago. So to know about the formation of Himalaya, we have to go little back, like 273 to 299 million years ago. So first of all, we have to know about Pangea. So what is Pangea? Pangea is nothing less than a supercontinent. Some all called it a megacontinent, but most of the geologists consider it as a supercontinent. So let me change the color of the pen. So what is Pangea? Pangea is a supercontinent. You can consider many continents merged together. Like this is a whole mass of land. There is no island, no separation, just a single piece of big mass of land. That is why it is called supercontinent. So is Pangea was there from the beginning of the earth? No. Pangea was formed by merging of small continents. So the big landmass is called Pangea. So what is this ocean called? Like this is a single ocean, no Pacific Ocean, no Atlantic Ocean, just a single ocean. This ocean is called Panthalassa. So when was it assembled? It was assembled back then when tiger had mustache. Sorry, I am joking. It was 299 million years to 273 million years ago during Permian epoch period. So where does the name Pangea get? So the name Pangea derived from the Greek word which means Pangea, which moreover which means all the earth. It was first proposed in 1922 by a German meteorologist called Alfred Wegener in his famous The Continental Drift Theory. So to know about the formation of Himalaya, we first have to know about the formation of the continents, then the formation of the two major supercontinents or megacontinents, and then we have to know how India was formed, how India was created. So Pangea was formed, then it was again deformed. During Triassic period, the Pangea masses, the Pangea landmasses began to break apart, and the cause was called continental rifting. This is a very controversial topic as many scientists support it and many not. The landmass eventually separated into two enormous continents. One is called Laurasia and one is Gondwana land. So who suggested the continental rifting theory? Wegener suggested. Wegener also suggested the major cause for the continents to shift apart is rotation of the earth due to the centripetal and the centrifugal forces result from the rotation of the earth. See, this was during the Permian period. I will discuss all the period in a separate video. So it was like 250 million years ago. Then comes the Triassic period. In Triassic period, the two enormous continent splits up. That is Laurasia and Gondwana land. Then India was a part of Gondwana land. See, this is our India portion. This is India and here it goes. So you have to have a rough idea about continental drift theory. So what is continental drift theory? In brief, continental drift theory is nothing but the falling apart of the major continents of Gondwana land and the Laurasia. They drifted and again they drifted and separated, and they move along the earth's surface. So this is called continental drift theory. The continental drift theory is the hypothesis that is the earth's continents have moved over geologic time relative to each other. This means that they are continuously moving in relative to time, thus appearing to be have drifted. You can consider the drifted to be the an synonym of slipped. They are continuously slipping with each other and with respect to each other. So what are what are tectonic plates? So how these are formed? So this is also a very controversial topic, as no one was there to prove actually what created the continental plates. So the continental plates are nothing but these were formed when, like, if you heat an object and cools it suddenly, it creates cracks. So earth was very hot during the beginning of the solar system. So when it cools, it breaks, the earth crust breaks into several pieces. So these pieces are called the tectonic plates. So and the movement of the tectonic plate is called the movement of the earth crust or the movement of plate tectonics. So there are mainly 7 tectonic plates present in the earth. So the largest of all is North American plate. The second largest is the Eurasian plate. The third largest is the Pacific plate, followed by the Australian plate, and all the other major plates are Nazca plate, South America plate, Scotia plate, African plate, Arabian plate, and Indian plate. So let us go to the plate tectonic origin. So how the plate tectonic started? So here tectonic means movement. So plate tectonic is the theory that the earth's outer shell is divided into large slabs. Here the large slabs mean the earth crust plates of solid rocks. They are formed of solid rocks and they are called plates that glide over earth's mantle. So there are mainly 3 layers of earth, that is crust, and beneath crust, that is mantle, and in the center part there is core. There are also various subpart. I will discuss them in a separate video. So what is mantle? Mantle is the rocky inner layer above the earth's crust, the earth's solid outer layer, which include the earth crust, the uppermost mantle. So the uppermost mantle, and in addition to the crust, is called lithosphere, which support the landmass of the earth, like the major canyon, mountains, drifts, troughs, etc. And the thickness of the lithosphere is 100 km. So according to Encyclopedia Britannica, this is called plate tectonics. If I say in simple word, plate tectonics is the movement of the plates of the earth's crust. Below the lithosphere there is a layer called asthenosphere. Asthenosphere is the separation between the cool earth's layer and the hot lava or magma layer of the earth. It is a viscous layer, means it is semi-liquid. It is partially solid and partially liquid, which kept us from the heat deep within the earth's crust. So it acts like a protection layer from the hot magma beneath our earth. It lubricates the underside of the earth's tectonic. So it acts as a lubricate so that it helps in the movement of the Earth's crust plates. So these are the two mega continents derived from the Pangea. One is called Laurasia and another is called Gondwana land. So India was a part of Gondwana land. So here it is Tethys Sea. So let me change the color. So this area is called Tethys Sea. Please note the name down as we are gonna hear it a lot in this video. So how Indian subcontinent was formed? Like about 225 million years ago, India was a large island, semi-island you can say, like a peninsula. It was a part of the Australian coast and which was the part of Gondwana land. It was separated from Asia by Tethys Sea. Like this area, it was called Tethys Sea. So when the supercontinent Pangea began to break up in 200 million years ago. So 200 million years ago, the Pangea began to break up and India started a northward drift. Means it began to move northward and thus collide with the Eurasian plate. So what was the speed of the movement? It was 16 centimeter per year to 5 centimeter per year. So it was variable. Sometime it was 16 centimeter per year and later it became slow and became 5 centimeter per year. So 71 million years ago India was here, like between the Australian coast and the Eurasian plain, and 55 million years ago it moves a little farther. 38 million years ago it moves a little bit more farther, and 10 million years ago it finally collided with the Eurasian plate. So now the main topic of this video, the formation of the Himalaya. So Himalayan mountain chain is nothing but a example of continental collision. So nearly 40 million years ago the Indian plate collided with the Eurasian plate. So this is the Indian plate and this is the Eurasian plate and this is the collision. So let me change the pen color. So how Himalayan was formed? Due to the collision, the enormous pressure forces resulting from the shock causes a gigantic mountain uplift. I will later show in this video how actually the mountain formed. So there are some fact like the total stretch of the Himalaya is 3000 kilometer. Like the collision was so huge, so gigantic that it result in a 3000 kilometer stretch of mountain and height of 8848 meter, 8840 meter. That is the highest peak and it is called Mount Everest. So just a minute. So this was the Indian plate and this was Eurasian plate. So when the collision takes place, the compression occur. Like if you give force, the compression always occur. So the compression of the force result in the upliftment of the sediments of Tethys Sea, and later when the compression was at its peak, the fold mountains occur. So let us see this diagram in detail. So this is our Indian plate ready to collide with the Eurasian plate. So the Indian plate is approaching and this is the course of the Tethasri. Like this is the geosyncline of Tethys. What is geosyncline? Geosyncline is nothing but the troughs present in the earth's crust where huge quantity of sediment deposit, like riverbeds and seabeds. So the oceanic plate, being a weaker plate, it subducts, you can say submerged. So the oceanic plate of the Eurasian plate comes below the Indian plate, and when the collision become enormous, the oceanic plate disappear due to upliftment of the Indian plate. So this result in the folding. Like the more the collision happens, it folds the sediments under huge pressure and temperature. So as we know that the continental plate cannot subduct below 40 or 50 kilometer, means that the Eurasian plate which was present from the beginning, it cannot subduct more than 40 to 50 kilometer. This result in the upliftment of the Indian plain. Thus Himalayas were formed. That is why Himalaya is also called a fold mountain. And in addition to Himalaya, another landform was formed, that is Tibet. This part of the Eurasian plate was uplifted from the beginning, and due to the collision, this fold exert pressure on this direction in the Tibet region. That's why this area also uplift but in a block manner, not in a fold manner, and creates the Tibet plateau. So this is the area where the fold occur due to the collision of the Indian plate and the Eurasian plate, as we see Himalayas now. So I am ending this video here. Bye bye. See you in next video.